Hello and welcome to vSphere design for Horizon View. In this video we're going to discuss some of the considerations for deploying your vSphere hosting infrastructure. We will look at the high-level design, the configuration maximums, and then finally look at some of the sizing guidelines and recommendations for designing a platform to host Horizon View and your virtual desktops. We aren't going to go into the intricacies of how to install and configure your ESXi hosts. However, we will briefly discuss the recommendations on how you should configure vCenter server, as well as the hosts and clusters within your Horizon View environment. It is technically possible to run your Horizon View and virtual server environments from one set of infrastructure, with one vCenter server and one or more ESXi clusters. By doing this, you would create a number of performance issues and make upgrading components a lot harder than it should be. As we've previously discussed, there are two sets of infrastructure for Horizon View. The management block that runs the vCenter server, composers and connection servers, etc. And then a second one that runs the virtual desktops themselves. As we've just said, the recommendation is that these two sets of infrastructure are separated physically onto different hosts and clusters to minimize any risk of performance with the server components, particularly during heavy usage periods or large desktop provisioning processes. From a licensing perspective, everything is covered, as included with Horizon is vSphere for Desktop, which basically allows you to deploy as many hosts and vCenter servers as you need to support your environment. So the diagram on screen shows an example of how your virtual environments could be designed. When building any VDI infrastructure, you can quickly and easily hit the configuration maximums that have been set. With vSphere and vCenter server, there are a number of maximums that you should be aware of. To check the latest configuration maximums for vSphere, follow the link that's shown on screen. You should also keep in mind that the Horizon View specific maximums exist. We will discuss these later in this course. Don't forget that these maximums are not goals to try and hit, but are maximum limits. When designing your architecture, you should also keep in mind what is the risk of losing an individual component, such as a vCenter server or even a connection server. As with any virtual infrastructure, you need to ensure that redundancy is built in as standard. This means ensuring that your servers have redundant power supplies, RAID hard drives, and multiple network cards for both failover as well as additional bandwidth. You also need to look at how many hosts are likely to be required to support your environment, and then add the relative amount of hosts to allow for N+ capacity that you require. In most environments, you will have N+1 to allow for any failovers. Remember that you are effectively going to be sizing for two different environment profiles. One will host the management block infrastructure, and the other will host the virtual desktop machines. So let's take a look at the CPU and memory, starting with overcommitting the CPU and memory resources. As a rule of thumb, you should never overcommit memory in a VDI environment. This can have many negative knock-on effects if memory is not granted when it's required, which will ultimately affect the end-user experience and performance. When it comes to CPUs, while it would be nice to not have to overcommit, this would simply not be affordable. CPU overcommitment, if done carefully and not pushed too far, can usually be allowed with little to no effect on the end users. However, the question is how far is not too far. This will generally depend on the type of workload you are running within your environment. If you look at various resources on the internet, you will find different answers to this question, with some claiming figures of more than 10 virtual CPUs per physical core. The only true way to find out is what's going on and what's acceptable in your environment is by reviewing the CPU ready figures. You can review this metric via vCenter or ESX Top or other tools. When reviewing the CPU ready figures, you should initially be looking to ensure that you are keeping CPU ready below 5% per virtual CPU for the desktops within your environment. Your environment might be able to accept CPU ready higher than 5%, but this should only be after testing during your POC and pilot stages. Generally, if CPU ready is as high as 10% per virtual CPU, the environment is going to struggle enough to affect the end user experience. So let's take a look at CPU and memory sizing. The number of hosts required for your Horizon View infrastructure is usually dictated by the number of desktops required, the amount of CPU and RAM these desktops require, what overcommit ratio you can allow for the CPU within your infrastructure, and how much CPU and memory you can physically actually fit in your host servers. When selecting your host server platform, you should also consider what effect it would have on the business if one host was to fail. As such, sometimes you might consider hosts with 2 physical CPUs to be a better design decision than having 4 physical CPUs, especially as the number of cores per CPUs continues to rise. It's trying to strike the balance between scale up or scale out and having fewer larger servers or spread the load across more lower spec servers. Ensure within your calculations that you are considering the overheads that the ESXi hypervisor requires to be able to run your virtual machines, as well as memory to be dedicated for graphics for virtual machines if that's a requirement. The following table on screen lists typical values or overheads in megabytes per VM. When it comes to networking, there are a few considerations for the networking in your hosts. So look at maybe 1 gig, 10 gig or 40 gig or whatever. No matter what, you will always want to ensure you have at least 2 multi-port network cards to separate your traffic to allow the resilient network design that you require. As to whether you require 1 or 10 gig for the VMLAN traffic within your infrastructure, it completely depends on the use case. If you are streaming a lot of HD media into your VDI desktops, then 10 gig might be required to cope with the additional bandwidth required. The other consideration is network latency and where users are actually connecting from. So using PCI over IP, for example, would mean anything less than 250 milliseconds would provide the best results. Anything over 250 milliseconds might be okay, but again this depends on what your end users are doing. Your assessment data will play a critical part in providing you with this information before you start designing. The requirements for graphics in your environment should be carefully considered and tested during the POC and pilot stages. You should consider all of the elements we discussed in the Horizon View architecture and its components section of this course, and then decide what is required with regard to PCI cards within your host servers to suit the graphics model you are going to deploy. The requirement for PCI cards for graphics acceleration or for offloading will affect the hardware you choose for your ESXi hosts, due to the limitations of some of these cards with regard to how much power and cooling that they need, but also the number of PCI slots that are actually available in the servers. We could probably write a whole course on storage considerations, designs and options with regard to your VDI environment. Storage is probably amongst the most important areas to get right. The first most obvious reason is that you don't want to end up with insufficient storage for your planned rollout, and the second reason is failure to specify a storage solution that's going to meet your performance requirements, which will leave your users unhappy or even a failed project. When it comes to storage, we need to look at 2 aspects: performance and capacity. So let's start with capacity. Your first consideration will be how much storage space you need for your Horizon View environment. You will need to consider where the relative elements of your virtual infrastructure are to be located. The first and easy bit is going to be totaling the required space for any server components. Often the server components will live on the same storage device as the rest of your virtual infrastructure, and the desktops will live on a dedicated storage device. However, this is not compulsory and will depend on the type of storage you are utilizing and the levels of separation you desire. You will then need to understand the required storage for your desktops based upon the technologies being used to deploy the desktops. So things like linked clones or instant clones, and whether we're using persistent full disks or whichever method we choose to build the desktops from. With linked clones, you need to have an understanding of the growth of the linked clone between the refresh and recompose operations. The diagram on screen gives an example of some of the areas for consideration when looking at storage for a typical desktop pool using linked clones and persistent disks. The replica from which a linked clone originates needs to be located on fast storage, either local to the host server or via a SAN. To enable this in Horizon View, you're able to choose the location of where the replica should live, and one of the recommendations is that this replica sits on fast storage, such as local SSD for example. The recommendation is that during your POC and pilot stages, you collect this type of storage usage information. Once you have this information, you'll be able to use a spreadsheet to create a model to predict the storage utilization, and you can grow your environment. The following screenshot depicts a sample Excel spreadsheet outlining the storage requirements across 3 different desktop pools. So let's now look at the performance elements of storage. Once you're aware of how much capacity you are going to use, you can start considering performance. As always, it is recommended that you understand your performance requirements during the POC and pilot stages, and use this to size your storage according. When examining your virtual environment, you're looking to keep the read and write latency as low as possible to guarantee a good end user experience. The amount of latency acceptable will depend greatly on the workload of your users and the tolerance of the applications that they are using. However, keeping average latency as low as 25 milliseconds will often deliver a good user experience. The question is how to ensure you can deliver this type of performance. The first thing to look at will be to deploy some form of storage acceleration technology to drive the IOPS. Horizon View has its own integrated solution called the View Storage Accelerator, or VSA, often called Content-Based Read Cache, or CBRC. This feature allows you to allocate up to 2 GB of memory from the underlying host server that can be used as a cache for the most commonly read blocks. As we are talking about booting up desktop OSs, the same blocks are required, and as these can be retrieved from memory, the process is greatly accelerated. But remember, CBRC is not required when you use instant clones. Another solution is the View Composer Array Integration, or VCAI, which allows the process of building linked clones to be offloaded to the storage array and its native snapshot mechanism, rather than taking up CPU cycles of the host server to deliver this. Remember, VCAI is not supported with instant clones. There are also a number of other third-party solutions that could also resolve the storage performance bottleneck. So the next question is, how many IOPS do you actually need? As with the question of how many virtual desktop machines can you configure per core, the answer to the IOPS question is also, well, it depends. If you read some of the guides and white papers on the subject, you would probably see something like Windows 7 needs 20 to 25 IOPS. That might be correct for steady state, but what about the peak disk activity? The only way that you'll know the answer to how many IOPS you need is from analysing your assessment report data. The following graph depicts a sample storage environment, showing a sample workload as the desktops are booted. Users log in and then continue to use the desktops. On the vertical axis you can see the IOPS, and on the horizontal axis you can see the time. As you can see, the boot storm is heavily read intensive, and the login storm and steady state being heavily write intensive, so you need to size accordingly based on this data. While the desktop may well drive 25 IOPS, what about the applications running on it? How many IOPS will they need? You don't want to find out the answer to that question after you've deployed your solution. There's also the debate around the split of IOPS between read and write. It's often quoted that the split is an 80-20 split, with 80 towards writes and 20 towards reads. But this again will be dependent on your environment, and the actual answer will be in your assessment data. It may well transpire that you have 70-30 or even 60-40, but again, your data will tell you this. As the IOPS requirements are a key part in the sizing exercise and can have a hit on the virtual desktop machine performance, you need to get it right. So let's have a quick look at some of the calculations. So one thing that gets forgotten when sizing is the RAID penalty or IOPS penalty when you write to a disk. This means that for every read operation, there will be multiple write operations occurring depending on the RAID level being used. For our example, let's take RAID 5, which has a write penalty of 4, and you need to deliver, say, 200 IOPS with a 60-40 read-write ratio. To calculate this, you can use the following formula that we've shown on the screen. Going back to the example, the calculation using the figures we've used above would look something like this. So in this example, you need to configure a RAID 5 array that could deliver the 600 IOPS that is required. Once you understand what performance and capacity you require for your VDI environment, you're able to select the most appropriate storage platform that will work for you and, more importantly, work for your users. In the next video, we're going to look at sizing the Horizon View specific components, such as the connection server.